9.4 Factoring to solve quadratic equations. Learning target: to solve quadratic equations by factoring. We're going to use the zero product property, which states for any real numbers, a and b, if a times b equals 0, then a equals 0 or b equals 0. And basically that's stating that in order to get a product of 0, you would have to have 0 times a number. So one of those numbers would have to be 0. So if x plus 3 times x plus 2 equals 0, then either x plus 3 has to equal 0 or x plus 2 has to equal 0 in order to get a final product of 0. So we're going to use the zero product property. This example here is already factored for us, so we have two binomials. So we have to assume that either 4t plus 1 has to equal 0 or t minus 2 has to equal 0 in order to get the product of 0. So we go about solving these the same way we would a regular equation, and we subtract 1 from both sides. So we get 4t equals negative 1, and we divide both sides by 4. So we have t equals negative 1/4. Now let's look at t minus 2 equals 0. We're going to add 2 to both sides, and we end up with t equals 2. So that means that if t equals negative 1/4, the product will end up being 0, and if t equals 2, the product will end up being 0. The last example already showed the factored form. The difference here is that we first will have to factor it. So going back to factoring, we need to remember that we're looking for factors of 15 that give us a sum of 8. So in this case, we can use positive 3 and positive 5. That would give us a sum of 8. So our factored form would be x plus 3 times x plus 5. And doing the factoring this way works because the a term is 1. And again, we need to remember to have equals 0. So looking at our factored form, we should be able to identify the fact that we can use the zero product property. One of these binomials has to equal 0 in order for their product to equal 0. So we have x plus 3 equals 0, and we have x plus 5 equals 0. So I subtract 3 from both sides, and I end up with x equals negative 3. I subtract 5 from both sides, and I end up with x equals negative 5. So in this problem, x can equal negative 3 or negative 5, and the result would give us 0. Number 2 is also using factoring, but if you notice here, it equals 18. It doesn't equal 0. Well, we need to set it up so that it will be set equal to 0. So we're actually going to subtract the 18 from both sides and rewrite our quadratic equation. So we have 4x squared minus 21x minus 18 equals 0. Now we can go and factor. This one has the a term greater than 1, so we have to do our steps. We have to find AC. And in this case, AC would be negative 18 times 4. So 4 times negative 18 is negative 72. So we need factors of negative 72 that give us a sum of negative 21. In order to multiply and get a negative, we're going to have a positive and a negative. So we have negative 24 times 3, because that will give us a sum of negative 21. So we're going to rewrite our b term in order to factor. So we have 4x squared minus 24x plus 3x minus 18. So on the left side, we have a 4x that we could divide by. On the right side, we have a 3 that we could divide by. So 4x gives us x minus 6. 3 is x minus 6. So our factored form is 4x plus 3 times x minus 6 equals 0. Now that was just our factoring part that we learned in Chapter 8. Now we're going to have to go on and solve the quadratic by setting each binomial equal to 0. So 4x plus 3 equals 0. X minus 6 equals 0. So we'll subtract 3 from both sides. 4x equals negative 3. Divide both sides by 4. X equals negative 3/4. Over here we add 6 to both sides, and x equals 6. So negative 3/4 or 6 would give us a product of 0. Now we're going to try using a word problem. Jason has a patio of uniform width around the perimeter of his rectangular pool. So let's start with drawing a picture. Here's our rectangular pool, and then we're going to have a patio around the rectangular pool. Now, it tells us that it has uniform width. Uniform width means that the width of the actual patio is the same all around the edges of the pool. Then it tells us the pool measures 22 feet by 12 feet. So this is 22 feet, and this is 12 feet. The area of the pool and the patio together, so the whole big rectangle, is going to be 504 feet squared. That's the area of the whole big rectangle with both of them together. We want to know the width of the patio. That's what we're trying to find out. Now, obviously, if the width of the patio is what we're looking for, we define our variable, x equals the width of the patio So that means that I have to look at my shape here. This here would be the width of the patio, and that would be x. You also can consider this side the width of the patio, which is x. And this could be the width of the patio, and this could be the width of the patio. So when I go to write my first equation, I'm going to look at my length of the pool and the patio together. So I'm looking at this length here that I just highlighted in black. So we're looking for the length of the pool and patio together. So that would be 2x plus 22. Now just to make sure you understand where I got that from, the distance of this first one here, as I'm pointing at this x, okay, that's a distance of x. Over here we have a distance of x, and then we have a distance of 22. So if you think about it as x plus 22 plus x, and I just condensed it to have 2x. Now we're going to do the width of the pool and patio that I just highlighted in black there. So keeping the same idea in mind, we have 2x plus 12 is going to be the width. So looking at what we just came up with, this is our length, and this is our width. And as we know, to find area, we do length times width. They told us the area was 504 feet, so I can set this equal to 504. Now I have an equation, but as we stated in all the examples we did earlier, in order for us to solve this quadratic by using factoring, we need it set equal to 0. So this problem is going to give us a little extra work. We're going to first have to FOIL and multiply our two binomials. So remembering back to FOIL, it's first. So 2x times 2x gives us 4x squared. Outside, 2x times 12 gives us 24x. Inside, 22 times 2x gives us 44x. And last, 22 times 12 gives us 264. And that equals 504. We combine like terms, and we have 4x squared plus 68x plus 264 equals 504. Now, in the example above, I showed you that when it equals a number other than 0, we want to make it equal 0. So we're going to subtract 504 from both sides. So now we have 4x squared plus 68x minus 240. And that equals 0. Now you could see this problem has a lot of steps because we haven't even solved it yet. We're just still setting it up. So we first had to define the variable. Then we had to write the equation. Then we had to FOIL so that we can end up setting our equation equal to 0. Now we can start our factoring process. Now when we go to factor, you see this number, negative 240, and you really don't want to have to multiply it by 4. But if you remember back to our factoring, if we can divide each term by the same number, we can make our number smaller. And these numbers can all be divided evenly by 4. And technically you would do it on both sides, but 0 divided by anything is going to still be 0. Now we always wrote the number 4 on the outside, and then we would end up with x squared plus 17x minus 60. Now in this case, remember we're looking for our two binomials when we finish our factoring. The 4 isn't going to play much of a part here in finding our answer. It just is going to make it easier for us to factor. So now we can find our factors of negative 60 and we need them to have a sum of 17. Negative 3 times positive 20 would give us a negative 60, and it would also give us a sum of positive 17. So now we can write our factored form. We have 4 times x minus 3 times x plus 20 equals 0. Now, as I stated a few minutes ago, the 4 really isn't going to have an impact on our answer. The x minus 3 has to equal 0, and the x plus 20 has to equal 0. So we're going to write those two equations. X minus 3 equals 0. X plus 20 equals 0. So we add 3 to both sides, and we get x equals 3. Subtract 20 from both sides, and you have x equals negative 20. Now this is a word problem, and we're thinking back to what the word problem asked us. It wanted us to find x, which is the width of the patio as we defined above. Now looking at our answers, negative 20 cannot possibly be an answer. You can't have a negative width of a patio. So that tells us that the width of the patio is 3 feet. So even though we got our two answers that would make the equation equal 0, the width of the patio would only make sense for one of those two answers. So for this one, your answer would be 3 feet. Now it's your turn to try. As you saw in the word problem that we just did, it does have some extra steps. I ask that you please take your time and give it your best effort, even if you have to go back and rewatch the part that I just did on the word problem. Try your best. Have a good night, and I'll see you tomorrow.